You are watching the 6.1 lesson video on Introduction to Quadratic Equations. Well, here we are talking about yet another type of function. And in this unit, we are going to talk only about quadratic functions, so giant U's. They're actually pretty amazing, the things that we can talk about and the things that we can do. And a really big piece of learning about quadratics is learning the vocabulary. There's different parts to a quadratic, and knowing the vocabulary and the different forms of quadratic equations is very helpful to figure out problems and kind of just decipher what is being asked and what is being given. So the first thing that I want to discuss with all of you is that there is such thing as a standard form of a quadratic equation. And it looks confusing, y equals ax squared plus bx plus c, just because there's a ton of letters in there, but it's really just writing the quadratic from the highest power to no power at all in that order, and y equals, or f of x equals. So we will use this form, I'll talk about this form, but we will also work in different forms of quadratics, and you'll see that as we carry on through the unit. All right, exercise 1. Label the following quadratic equation with the following vocabulary words. And then we're going to write the numerical values next to each word. Okay, so vertex. The vertex has many names. The vertex and the turning point and the maximum and minimum are actually the same thing. Okay, we just sometimes refer to them using different words, sometimes for no reason at all. So if I tell you find the vertex, you are going to find the highest or lowest point on the entire graph. That's the same thing as a turning point. So we can actually label this with vertex. This is also the turning point. And we need to decide whether this is a maximum or a minimum. In this case, because the graph is the lowest point, this will be our minimum. You got it. Now, if this U were flipped upside down, something like this, we would actually refer to it as a maximum point value. We'll see that probably later at some point. Okay, so if we want to label the vertex, that is just a coordinate. The vertex is a point. So this is a point, -1, -4. And I can just copy that and paste it. Boom, boom. Oops, -4. I was going so fast, I almost forgot that negative sign. He's a big deal. -1, -4. All right, moving on. The next piece, I want to talk about roots, zeros, and x-intercepts. They're pretty much all the same, but sometimes we label them a little bit differently based on the words that they use. I'll tell you about that in just a minute. The roots are the places where that parabola crosses the x-axis. Okay, so we typically have 2. Sometimes we have 0, and sometimes we have 1. If we just had 1, the parabola would, I'll give you an example, it would just like touch one point and bounce back up again. Ew, that's a horrible graph. But that's how you would only have one root, 1, 0. Sometimes your parabola might be floating above or below that axis, like so down here. And therefore you would say it doesn't have any roots at all. But lucky for us, this one does, and these roots are here. So let's label. There's a root, there's a root. We can call them roots. We can also call them zeros. And we can also call them x-intercepts. Now, the roots and zeros are like potato, potato, the same thing. So our roots are the x values, so x equals -3, and x equals +1. And the zeros we write out the same way. X equals -3, x equals 1. Sometimes you might see it written in set notation, not typically in algebra. The x-intercepts, on the other hand, we write out as a coordinate. So that would be the point -3, 0, because 0 means we would not go up or down, and 1, 0. All right, I'm going to use green for the y-intercept. You guys know this already. There it is, the y-intercept. The place where it crosses the y-axis. So this is at the point 0, because we didn't go left or right, but we went down 3. And last, but certainly not least, is our axis of symmetry. Now, the axis of symmetry is pretty special because this axis here is how the entire graph can pretty much be folded over. So my axis of symmetry, I'm actually going to use this highlighter. That's kind of cool to draw it in. Okay, so there is my axis of symmetry. And see how it passes right through the vertex? That will happen every single time. Very cool. Now we need an equation for that. Okay, so what value is always going to be -1 every single time? The x value or the y value? Well, if you need help, look at your vertex. X equals -1. And if you're not sure, you can put a point there. That's a point -1, 1. This is a point -1, 2, -1, 3, -1, 4, -1, 5. Get my drift? It's always -1, or x is always -1. Okay, here we go. Exercise 2. It says read the definition above for quadratic functions and answer all the following questions. A, circle the choices below that are quadratic functions. Okay, so the quadratic functions are going to take this form. I actually don't, what do they mean by read the definition above? I guess those directions are kind of not useful. So I'm going to talk you through this anyways. All right, so A, circle the choices below that are quadratic functions. I am going to use a highlighter because I think they're fun. Quadratic equations or quadratic functions have the highest power that is squared. So this is a quadratic function. This is a quadratic function. This is not. You probably recognize that that is an exponential from a couple units back. And because this one has a 3rd degree, this is a cubic and is not a quadratic because it had a power higher than the x squared. Okay, so B, moving on, we need to write this function in standard form. This means we just write it from highest power to lowest power. Actually, I would highlight that standard form. This is a big deal. I'll talk about this a lot. Okay, so make sure the signs stay the same. So the -3x squared, that's the highest power, plus 7x, he's positive, and then the 10 is also positive. Notice how the signs of my numbers stayed with the value. All right, the leading coefficient is -3 because it is the coefficient of the x squared. So we're always going to look for the x squared term when we're looking for the leading coefficient of a quadratic. And in C, let's move on to C now, we need to find f of -2 given this function here. Remember, we've talked about this before. Just means that we're replacing x with a -2. There's a few ways that we can do this, but I would like to go through the algebraic method using order of operations, but we will get to use our calculator quite a bit this unit. All right, let's simplify. So exponents. -2 times -2 is a +4. And everything else stays the same. PEMDAS. So after exponents, we then, you got it, multiply. So 8 plus 6 plus 1. So if I input -2, I get a value of 15 out. I could also say that this is a point -2, 15. Oh, hey, I just answered my next question. I didn't even realize that. So what point lies on this quadratic graph? The point -2, 15. Because my x value is 2 and my y value is 15. Okay, onward to the second page. Consider the parent quadratic function. We have seen these already in Unit 2. So all we're doing is squaring our x. So 3 squared. 3 times 3 is? Why is this not writing? 9. 2 times 2 is? 4. 1 times 1 is? 1. 0 times 0, this is just 0 squared. This is what I'm doing right now, 0. So that was 1 squared if you just needed a little memory jog. This is all I'm doing. And the same thing happens with these values over here. A negative times a negative is a positive. So if we head over here and plot these points, I like to start with my vertex. I can see that it's my vertex because do you see how these points are all connected? The 1s match up, the 4s match up, the 9s all match up. I like to plot my vertex first. I don't know, it's just a thing I like to do. You don't have to do it that way, but I think it helps to plot my points because sometimes when I don't do that, they get out of line. Did I do that right? I feel like I'm not counting right. I don't. Okay. And instead of connecting with straight lines like an exponential, we do our best to draw a curve. Oh my goodness, look at that side. Crazy. All right, and I'm going to label this is f of x. Now the range. The range, remember, is the y values. So what do you notice about all the y values? Well, they don't go any lower than 0, but they go up all the way to infinity. So a way that I'll represent that is y is always going to be bigger than or equal to, well, what was the lowest point? 0. Okay, so exercise 4, we need our calculator. So it says, specifically, use your calculator to help generate a table of values. Sweet. So let's do a new document, add a graph, and I am going to graph x squared minus 2x minus 8, and Control T to see my table of values. Now, we want to pick the points that are the most significant to us. So I'm going to see if I can find that turning point. So where do we see those numbers start turning around? Oh, we got it. So I'm going to, I think, how many points can I get in here? From -2, -1, 0, 1, 2, 3, 4. Is that going to work? Let's try it. So -2, 0, -1, -5, 0, -8, 1, -9, and then 2, -8. This is how I can see that 1, -9 is my vertex. And I really don't even need to look at my calculator because the rest of those points should match up. That's amazing. Okay, and then let's graph it. So -2, 0, -1, -5. My y-intercept is 0, -8, so 5, 6, 7, 8, 1, -9. And since that was my vertex, this cute quadratic is just going to bounce right back up again. We're going to connect using a curve, cover that whole graph, arrows on the ends of the lines. You got it. Now, we got to find the range, the y values, okay? So the y values, well, there's our minimum. So they start here and then go up to infinity. So we can say y is always going to be bigger than or equal to. How low is that? Well, that was -9. And you can see that actually right in the table. The smallest point here of my y values is -9, and it only goes up from here. All right, C, over what domain interval is the function increasing? Increasing. Okay, so that means going up. All of those values here. So we are looking at this all the way over to that way. X values, domain, the x's. So that means that x is always going to be bigger than, not equal to, we never include the turning point, but what is this x value here? It's 1. So it's always increasing when x is bigger than 1. On the flip side, you could also write it in interval notation, 1 all the way to positive infinity. Sometimes I see the inequality notation works a little bit better. Well, we've already talked about the turning point slash vertex slash minimum over and over and over again. That's right in this table here, 1, negative 9. And then lastly, draw the axis of symmetry. Okay, well, I kind of already wrote that in there when I was looking at the increasing interval, but here is our axis of symmetry and write its equation. So what is that equation? Well, that's x is equal to 1 and x is equal to 1. And you know what I just thought about? I think I got to go back. I think I was bad and we didn't. That is right. We were supposed to, on page 1, label our axis of symmetry with the word hello. We need to do that. I'm so sorry. That was so important. Okay, I'm feeling much better. All right, I know this video is getting pretty lengthy, so hopefully I have had you start this or given you some time to do this in class. You guys told me that you like the videos to be less than 15 minutes. So if I didn't do it at this point in time, you can come into class next time and politely remind me that you wanted the videos to be less than 15 minutes. All right, so here we go with exercise 5. We're almost done. The quadratic function has selected values shown in this table, and we need to find the coordinates of the turning point. So remember, that turning point has that nice pretty pattern on both sides. So as soon as we start to see that repeating of the numbers, I'm not seeing it, 12, 12, here it is, 12, 12, 9, 9. So the vertex, the turning point, is this guy, this point that falls right in between. And then the range, remember, the range we can see in the y values. So let me just highlight that in a different color. Range. So the range would be all of the points compared to that 13. So what do we notice about all of these y values compared to 13? Well, they're definitely not getting any bigger. They are getting smaller. So we will use a less than, and because 13 is in the table, it can equal. So y is less than or equal to 13. Another way we could write that is in interval notation. So it starts at negative infinity, but it only goes up to 13 and stops right there. All right, I hope you enjoyed the wonderful first day of quadratic functions.